Okay, this is 7.3 in your textbook, page 399. We're looking to create and test conjectures about properties of quadrilaterals. So we're basically looking at a whole bunch of different shapes. Quadrilaterals, again, being shapes. We're looking particularly at the kite for the first time. So we're going to create and test conjectures about properties of quadrilaterals. The kite is a quadrilateral that has two pairs of equal sides with no sides parallel. So that's what these dashed lines mean. They mean that this side is equal to this side. Same thing as this double dashed lines means that this side is equal to this side. So they have two pairs of equal sides, but no sides are parallel. So we know something is parallel when it lines up exactly the same way, in the same direction. In this case, we have no lines that are like that. Okay? So that's a quadrilateral, which is called a kite, when we have that situation. Okay, conjecture, we know from the last chapter that it's a guess or hypothesis or prediction based on limited evidence. Okay, so we're using that definition again, so be familiar with those two. There's not much to this lesson other than this table. Okay, in this table you can find a better version of it on page 400 at the bottom. This is really what you want to memorize. You know, sadly, it is a kind of a situation here in math where sometimes we need to have these memorized. You don't need to. You can figure out the properties of each, but it makes things a little easier if you can memorize this. Okay, so be familiar with this table. So what we're doing then is we're just going over the shape and then the particular properties of that shape. Okay, so if we have a square, we know the diagonals are equal and bisect each other. Okay, so when we draw a square, if we draw the diagonals to the square, we know that those diagonals bisect each other. Anybody knows what bisect means? Bisect. Yeah, Michael.
Splits equally in half.
Right, good. So it's not enough to say that they intersect each other. When we say bisect, so here's my square. When I say bisect, it means that they cut each other exactly in half. Okay, so that's very important. So that this side is equal to this side and this side is equal to this side. This is especially important when you get into problems where you're given information about this side. You know if it's a square, then you know that that side is going to be equal to that length, also equal to that length, and equal to that length. Okay, so if you can imagine what the questions are going to be like, they're going to give you part information, and you're going to need to know the properties of that shape to figure out what the lengths of the other sides are. Okay, so the next one, rhombus. It's not a square. Remember what a rhombus is that the four sides are the same length. Okay, but we're not talking about a square in this situation. So even though a square is a rhombus, we're talking about all other rhombuses besides square. Okay, so all other rhombuses besides square, the diagonals are not equal, but they do bisect each other. Okay, so if we don't have a square per se, our angles are not all 90 degrees, so they're different angles than 90 degrees. When we draw the diagonals, we know they're still going to split each other in half. Sorry, we know that they're not going to split each other in half. They're not equal. Okay, but they still, and they bisect. So the diagonals are not equal and they bisect. So they cut each other in half, but the diagonals themselves are not the same. Okay, so a square, this diagonal length is the same as this diagonal length. In a rhombus, this side is equal to this side, but they're not the same length of diagonals themselves. Okay? Next one is a rectangle. Not considering a square, so although we know a square is a type of rectangle where the sides are the same, we're considering a rectangle where the sides are not the same. So we know they're equal and they bisect. So these two diagonals are equal and they also bisect. Okay? So equal, the diagonals form angles that are equal when opposite and supplementary when adjacent. I'm just going to finish up here. What supplementary means is that the two angles combine to give you 180. Okay, that's what supplementary means. When they're opposite, the angles are the same. When they're adjacent, they're supplementary. Okay, go through the rest of the table on the shapes, then try and do your homework, 7.3. Okay, we'll take up any questions that you have with the homework tomorrow.